So I'm going to look at dividing whole numbers using two approaches, short and long division. We're going to begin in this video using short division. And then in the next video I will look at long division and compare it to the short division approach. More than likely you will be required to solve particular division questions without using a calculator. So it is important to develop an understanding of approaches in order to do this. When working out division problems using the short or long method, there are two particular situations you need to consider, and I'll discuss these as we go along. So let's look at this question here, 834 divided by 3. Before we delve into solving the problem, let's think about what the problem is saying. It is saying how many times does 3 go into 834? Looking at this on a number line, here's 0 and here's 834. How many lots of 3s will it take to get me up to 834? So 3 multiplied by something is going to equal 834. And by doing this division, we're going to work out what that something is. Now, whether you're doing the long or short method, this is how you set the problem out. Because we are trying to work out how many 3s there are going into 834, we need to be thinking about the 3 times table, or basically multiples of 3. Well, here are some multiples of 3. Now, unlike the traditional multiplication approach where you start with the units and work your way up, that is, you're going from right to left, this time with division we go from left to right, hence the layout with the 3 to the left of 834. And again, with both the short and the long approach to division, we work along digit by digit. So starting with the digit 8, which is 800, we do the division 8 divided by 3. 3 goes into 8 2 times. 3 multiplied by 2 is equal to 6. But we've got this 2 left over because we actually were trying to divide 3 into 8. And this 2 left over is what we call the remainder. So 8 divided by 3 you can think of as 2 remainder 2. The 2 goes on the top line in the hundreds column above the 8. And the remainder 2 goes next to the 3, which is in the tens column. We now think of this number here as 23, and we're going to divide this 23 by 3. Well, 3 goes into 23 7 times. 7 3s are 21, and there's a remainder of 2. So we write the 7 down on the top line in the tens column above the 3, and we write the remainder next to the digit 4, and that's 4 units. We now do 24 divided by 3, and 3 goes into 24 8 times. So our answer is 278. So 3 multiplied by 278 is 834. We can also say that both 3 and 278 are factors of 834, and as 3 is a prime number, 3 is also a prime factor of 834. Let's try another one. 645 divided by 5. We can see that because 645 ends in a 5, it must be divisible by 5. All whole numbers that end in a 0 or a 5 are divisible by 5. But we need to work out what that is. Looking at this on a number line, the question is asking how many times does 5 go into 645? 5 multiplied by some number is going to equal 645. So let's set the problem out. And because we are dividing by 5, we need to be thinking of the 5 times table, or multiples of 5. We begin with the first digit 6. 6 divided by 5. Well, 5 goes into 6 one time with a remainder of 1. So we write the 1 down above the 6 in the hundreds column, and we write the remainder 1 next to the 4. We now do 14 divided by 5. Well, 5 goes into 14 2 times because 5 2s are 10. And there is a remainder of 4. So we write the 2 on the top line above the 4, and we write our remainder of 4 next to the 5. We now do 45 divided by 5, which of course is equal to 9. So the answer is 129. 5 and 129 are therefore factors of 645, and because 5 is a prime number, it is also a prime factor of 645. If you feel confident enough, have a go at the next question, 702 divided by 6. Pause the video, have a go, and when you're ready, press play. But I'm just going to go through the answer. So the question's asking, how many times does 6 go into 702? We set out the problem, and because we are dividing by 6, I need to be thinking about the 6 times table, or multiples of 6. Working from left to right. 7 divided by 6. Well, 6 goes into 7 one time, and there's a remainder of 1. We write the 1 on the top row, and we write the remainder next to the 0 in the tens column. 10 divided by 6. Well, 6 goes into 10 one time with a remainder of 4. We write the 1 on the top line above the 0, and we write the remainder next to the 2. 42 divided by 6. Well, 6 goes into 42 7 times. Our answer is 117. So 6 multiplied by 117 is equal to 702. Therefore, 6 and 117 are both factors of 702. Now, in these 3 examples, the first digit of the number that we were dividing into, so in the case of this last example, 702 divided by 6, the first digit, 7, is bigger than the 6. So when we did 7 divided by 6, we had 1 with a remainder of 1. But let's look at this example here. 1000 divided by 8. So how many times does 8 go into 1000? Let's tackle the problem. If we set it out and begin our division, the first digit we're starting with is 1. How many times does 8 go into 1? Well, of course, 8 is bigger than 1. So this is our second type of problem, where the first digit of the number that we are dividing into is smaller than the divisor, the number that we are dividing by. So what do? How many times does 8 go into 1? Well, of course, 8 goes into 1 0 times with a remainder of 1. So we would write the noughts on the top line above the 1, which is in the thousands column, and write the remainder next to the 0, which is in the hundreds column. We would then do 10 divided by 8. Well, let's just stop there a minute. We've done an unnecessary extra step. If you look at the first 2 digits of the number 1000, those first 2 digits are 10. So in this situation, where the first digit is smaller than the divisor, let's just read the first 2 digits instead. So what is 10 divided by 8? And of course, 8 goes into 10 one time with a remainder of 2. Write the 1 down, write down the remainder. We now have 20 divided by 8. Well, 8 goes into 20 2 times with a remainder of 4. And that leaves us with 40 divided by 8, which of course is equal to 5. 5 8s are 40. 8 goes into 1000 125 times. So 8 multiplied by 125 is equal to 1000. 8 and 125 are factors of 1000. Let's look at another problem. 747 divided by 9. So that's how many times does 9 go into 747. We'll set out the problem, and this time we're thinking of the 9 times table. 7 divided by 9. So 7 is smaller than 9, which would mean the answer would be 0 remainder 7. So we would write the 0 down up here, and then we'd write the 7, the remainder, next to the 4. We then have 74 divided by 9. But of course we actually didn't need to do that step. Because the 7 is smaller than 9, instead of looking at the first digit, we look at the first 2 digits, which is 74. We now do 74 divided by 9. Now 9 goes into 74 8 times because 8 9s are 72. So 74 divided by 9 is 8 with a remainder of 2. And notice where the 8 is going. It is going above the 4, not the 7. Remember when I showed you the problem initially, we put a 0 above the 7 because we had 0 remainder 7. What you could have done with this problem, just so you don't get caught out, so you could have said, right, 7 divided by 9. Well, 9 is bigger than 7, so I'm going to put a 0 above the 7, and then say 74 divided by 9. Do that if you want to, just so you don't write the next digit in the wrong place. So we've written the 8 above the 4, we've got our remainder of 2. We now have 27 divided by 9, or how many times is 9 going to 27? And of course the answer to that is 3. 9 goes into 747 83 times. So both 9 and 83 are factors of 747. 546 divided by 7. So how many times is 7 going to 546? We'll set out the problem. And because we're dividing by 7, I'm thinking of the 7 times table. Working from left to right, our first digit is 5. 5 divided by 7. Well, 5 is smaller than 7. So I now need to look at the first 2 digits instead. 54 divided by 7. And you might want to put a 0 above the 5 so you don't write the digits to your answer in the wrong position. 54 divided by 7. Well, I know that 7 goes into 54 7 times because 7 sevens are 49. And that's going to leave us with a remainder of 5. So I write the 7 down above the 4 and write down the remainder of 5 next to the 6. 56 divided by 7 is equal to 8, because 8 sevens are 56, which means that both 7 and 78 are factors of 546, and because 7 is a prime number, it is also a prime factor of 546. 2 more questions. These are going to be wordy ones. 7 people share a lottery win of £868. How much did each person get? So we're going to do the calculation 868 divided by 7. So we set out the problem and work our way through, working from left to right. 8 divided by 7. 7 goes into 8 one time with a remainder of 1. 16 divided by 7. Well, 7 goes into 16 2 times because 2 sevens are 14. And there's a remainder of 2. 28 divided by 7. Well, 7 goes into 28 4 times. So each person is going to get £124. And that's our answer. A chocolate cake containing 744 calories is split into 8 slices. How many calories are there in each slice? So there's our problem, 744 divided by 8. So we set this out. Working from left to right, we have 7 divided by 8. Because 7 is smaller than 8, we therefore look at the first 2 digits, which is 74. 74 divided by 8. Well, 8 goes into 74 9 times because 9 8s are 72. with a remainder of 2. We're then left with 24 divided by 8. Well, 8 goes into 24 3 times because 8 3s are 24. The amount of calories in each slice is going to be 93 calories. So there's a brief introduction to division without a calculator using the short method. So in the first types of questions we looked at, the first digit of the number that we were dividing into was bigger than the number that we were dividing by. And for the second set of numbers we looked at, the first digit of the number that we were dividing into was smaller than the number that we were dividing by. So you need to be aware of what to do in both situations. In the first situation, it's not a problem, but in the second situation, you need to think about what to do. And that is, the first calculation you do involves the first 2 digits of the number that you are dividing into. And as I mentioned as a tip, if you do have a situation where the first digit is smaller than the divisor, then put a 0 above the first digit, so you don't write your answer in the wrong column. I do think it's important to think about the mathematics surrounding these problems, which is why I wanted to look at these problems on a number line and think about factors and prime factors, because these topics are connected. In the next video, we're going to compare this method to the long method. They are very similar. It's just that the layout is different. Then you can decide which approach you prefer. I hope you found the video helpful. If you did, don't forget to like and subscribe. And thank you for watching.